In this video, we are looking at practice number 26. That is in your Book 2 workbook of the TABE Tutor Practice. And the lesson starts on page 6. So if we turn over to page 6, this is about identifying and generating equivalent expressions. Number 1, which expression is equivalent to 8 times the difference of 3y and 5? So 8, 3y minus 5. So we are going to multiply using distribution. 8 times 3 is 24y, and 8 times 5 is 40. So I like D for this one. 24y minus 40. Number 2. Harvey buys 2 hoagies, 3 sides, and a drink. The total cost can be represented by the expression. Which expression is equivalent to the total cost? Well, 2h plus 3s plus d. None of these terms can be combined because they are not like terms. They're not the same variable. What I would think of doing, though, is to standardize this, and that means to put it in alphabetical order and see if this is one of our choices. And I'm thinking that it is B. You can add in one direction, you can move the terms around and still add without changing the value of your answer. That's called the commutative property. But these two things mean the same thing. Number 3. Which expression is equivalent to this one? So we have 4a plus 2b minus 8a minus 2b. Now, because there is a subtraction sign in the middle of this expression, I want you to go ahead and put that ghost 1 in there. Let's put a coefficient of 1. And then we need to distribute that coefficient of 1. So the first part of this will not change. But here I have negative 1 times positive 8. That's a negative 8. And then negative 1 times negative 2 is positive 2b. And then I want to group my like terms. I have 4a minus 8a. That's going to leave me with negative 4a's. And then we have a positive 2b and a positive 2b. That is positive 4b. So I'm looking for something similar to this one. And it looks like what they have done here, none of my choices match exactly. So I need to keep working with this expression a little bit. They have factored out the negative 4. So they've pulled the negative 4 out. That's left with an a minus a b. So I'm thinking option C would be the equivalent. Number 4. When warming up, Michael follows a pattern of 10 squats, 7 push-ups, and 20 jumping jacks. He repeats the pattern 5 times. Michael represents his warm-up with the expression, which 3 expressions are equivalent to Michael's warm-up. So we are looking for expressions that are equal to this one. So the first thing I'm going to do is take the expression that Michael wrote and simplify that. Let's see if we can get a match if we simplify. So I'm going to distribute the 5. So I get 50s plus 35p plus 100j. And I see that one is D. So here's one of them. We need 2 more though. So looking at this one, the first one, if I use distribution, I don't want to multiply S times P. That is not one of the things that I want to do. So this is not one of the choices. 50s plus 7p plus 20j, that one would be okay if we had a 5 right here. But we can't forget about this distribution. So this one would not work either. C is 50 of the squats, 50 of, I lost my place, I'm sorry, 35 push-ups and 100 jumping jacks. That is equivalent. The numbers match up on that one. They're just in a different order, and that's okay because we're adding. We can move them around. So we have 2 of our answers. We're looking for a third one. This one, I have 50s, 35p, 100j. It's perfectly fine to group 2 of them. We're not changing the value at all. So yes, this is one of them also. And in F, we cannot add 5. We need to multiply that 5. So that one is not an option. So for number 4, I would go with C, D, and E. Number 5. Which expression is equivalent to this one? X plus 2 times x minus 2. Now if you remember from the instructional video, this is called multiplying binomials. And we do that with that process called FOIL. The acronym FOIL stands for first, outside, inside, last. So let's take a look at these first 2 terms. First terms, I don't want to leave those highlighted, sorry. X and x. So x times x is x squared. Outside would be the x and the negative 2. X times negative 2 is negative 2x. Inside is 2 and x. So positive 2 times x is 2x. And last is positive 2 times negative 2. 2 times negative 2 is negative 4. So let's look at our choices and see if we need to simplify on further. Remember, sometimes they will have us to go ahead and combine those like terms, but in this situation they did not. They have put this together exactly the way it came out. So they have x squared minus 2x plus 2x minus 4. And they've chosen to put parentheses around them, but that doesn't change the value at all. So the answer we want is D. It is not fully simplified, but that's okay. It depends on your problem and how you need it to be set up. So this one does not need to simplify all the way. Okay, number 6. Which expression is equivalent to 48x plus 18? So this one has to be factored. Instead of distributing a term, there are no parentheses, we're going to divide out a term. So I want to know what the 48 and the 18 have in common. So I'm going to list my factors for each of those. So 48, we have, let me put this in a box. We have 1 times 48. We have 2 times 24. We have 3 times 16. We have 4 times 12. 5 won't work. 6 times 8. And then 8 times 6, we're starting back up the line. So those are the factors of 48. The factors of 18. Let's see what we've got on this one. We have 1 and 18, 2 and 9, and then 3 and 6. So the greatest common factor between these two looks like the 6. It's the biggest one that they both have. So that's what I'm going to factor out of this expression. So I'm going to pull out the 6. 6 into 48 is 8 times. So there's 6 8x, that's 48x if you multiply it. And then 6 into 18 is 3. So hopefully this expression is present, and it is. This is going to be A. So instead of distributing, building up this time, we are breaking down. Number 7. Seth has $25, earns $15 per hour, and buys 2 notebooks. His finances can be represented by which expression is equal to Seth's finances? Well, here's what we have to work with. The first thing I would want to look for is whether I can combine any terms. Do we have any terms that are alike that can be combined? And we don't. There's nothing to be factored out because 25, 15, and negative 2 do not have a common factor. So really the only thing that I might be able to do is rearrange the order or put in some parentheses. So let's try some parentheses here and see, and sure enough, that is answer B. So you just have to think through these. There's no math to do. This is called the associative property, where you can add things in any order without losing a value. Which expression is equivalent to 4 times 4 times 4 times 4 plus 4y. So I want to ask myself, are there any terms that can be combined? And there are. These 4's are all constant. They're like terms. They're all 4's. So I'm going to say 4 to the 4th power because there are 4 of them plus 4y. And so I like option A on this one. 4 to the 4th power is much easier to look at than all those 4's. Imagine if it were like 4 to the 20th power. You wouldn't want to look at that row of those. It's much simpler and cleaner to use the exponent. Number 9. Andy slices avocado, banana, and cantaloupe for both of his children. The number of fruit slices can be represented with the expression. Which expression is equivalent to the number of fruit slices? The first thing you want to always check is whether you can combine like terms. And we can. There are actually 3 situations here where I can combine like terms. Let's first of all combine the avocados. So we have 4 avocados plus 3 avocados. That's a total of 7 avocados. Okay, we could combine our B's. B's are bananas. So B and B, that's 7B. And then we could combine the cantaloupe. 4 and 2, that's 6C. So when I look at this, I don't see that expression listed. Even though it is a correct expression, unless I've made a mistake, and I have, of course. That's the second thing I always check. Do I have my numbers copied correctly? And I don't. Look at this expression and look at what I did. This term is wrong. So that's a very good little strategy. If it's not coming out right, check to make sure you've copied it right. Because when I adjust the avocados, and I bet some of you saw that and you were thinking that she's doing it wrong, I get the correct answer. I get 5A plus 7B plus 6C, and that is one of my choices. That was not intentional. I made a mistake, which I do a lot, but I have learned to go back and check to see if I copied it wrong, and that's a good strategy for you. I could have just cut this problem out and started over and you would never have known I made a mistake, but I think it's worthwhile to show you that mistake and how you can fix that, because that might help you too. Number 10. Which expression is equivalent to 2y plus 5 over 11 plus 4y? Okay, this one is pretty complicated. I will tell you that we don't have to do any math. We just have to think through this carefully. And it is called, it's actually part of the distributive property. Okay, so what I'm going to do is to split. I'm really not splitting it, I'm just breaking it into its parts. This piece right here. So I want you to focus with me right here just a minute, because this very ugly piece of the problem can be broken down like this. Put the 2y over 11 and put the 5 over 11, and then let's not forget about our 4y. Okay, so all I've done there, and I say all I've done, it's pretty complicated to look at. I have just separated that fraction out into two separate fractions, and that of course matches with D. That one's pretty rough, especially if you've not seen the instructional video. And even having seen the instructional video, this is a tough one. All these are. This is a tough exercise. Number 11. Tom and Scott take care of 4 cats, 4 dogs, and 2 ferrets. They represent the situation with the expression here. Tom says that this is an equivalent expression. Scott says that this is an equivalent expression. Which 2 statements are true? Well, I'm going to start with Tom's expression. And on these kinds of problems, I like to keep the name with my problem. So we have Tom's expression. I don't know if you hear that horrible noise. I live far off the road, but it sounds like there's a convoy of tanks going down the road. So if you hear that, I apologize, that roaring. So Tom could simplify his expression. And we have 4c plus 4d plus 2f. That looks like the original expression. But let's look at Scott's and see what he has, because they could both be right. We have 4c plus 4d plus 2f. So in Scott's expression, he has put parentheses around these two. And it's fine to do that. So either of these expressions is correct. Scott is correct because he used the associative property. That's rearranging addition or grouping addition. That's perfectly fine. Tom is correct because he used the distributive property and he did it correctly. So they're both correct for different reasons. They use different properties, but they both have equivalent expressions. Number 12. Carol uses the formula to find the area of a trapezoid. Which other formula could she use? And this one just looks scary. But let's see if we can simplify it a little bit. Here is the formula. I'm going to leave off the A part. I just want to write down the 1/2 H A plus B. So I'm going to think about that. The first thing I notice is that fraction, that denominator of a 2. So what if I took this 2 and moved it over here? Could I do that? Let's see, if I brought the 2 over here. So I would have 1H A plus B over 2. Sure, I could do that because I still have that denominator of a 2. I've just made it the denominator for the whole expression. What could I get rid of? What could just float away? without changing the value. This 1 is really a ghost 1. It could just disappear without changing the value. Remember, you can put the 1 in, you can take the 1 out, and you have not changed your value. So let's see if we can find something like this. And there it is. Do you see it? It is B. We've just rearranged the numbers without changing the value. That's what's so important. We can't change the value of the expression, but we can rearrange the pieces as long as we are following the rules of math. And this is the commutative property, and distributive really, if you're keeping up with those. I want you just to be able to follow the logical movement. You don't have to remember those terms. Number 13. Which expression is equivalent to this one? Now, my first instinct is to FOIL this one, and I think I'm going to go ahead and FOIL it for you just because I want to practice that. But this is not the answer. I'll just tell you up front. And I know that. Let's get FOIL and then I'll tell you how I knew it. So first terms will be the 2x and the x. So that's going to be 2x squared. The outside terms will be 2x and positive 4. So that is 8x. The inside terms will be negative 3, x and x. So that's negative 3x. And then the last terms would be a negative 3 times a positive 4, which is a negative 12. But the way that I knew that FOIL wasn't my method here is because there are no squared numbers in this anywhere. There are no second powers. So FOIL is not the route that we wanted to go here, and I knew that up front because there are no second powers. And remember, with FOIL sometimes you do combine these two. But FOIL is not what they want here. Even though it was an option, it's not what they wanted to do. So let's look at moving things around. Is it possible that they have moved around some of the terms? And here it is. They sure did. All they did was reverse the order of the binomials. They put the x plus 4 in the front. They just reversed the order. They didn't change the value. They just flip-flopped those parentheses. So I didn't have to go through FOIL, but it's good practice to do that. And let's go ahead and finish FOIL. Simplify it. 8x minus 3x is 5x. So this could have been a choice if they had so chosen. I like FOIL. I'll do that every time if I can. Number 14. Which expression is equivalent to 52x minus 72y minus 21? Now I have two choices here. I can factor or try to factor, or I can see if they have moved things around, and I'm going to do the moving around first because that's the easiest one. Are there any of these that just reversed the order of the terms? And there is. It is A. You have a negative 21, a negative 72y, and a positive 52x. So this one is equivalent. Off the top of my head, I'm not sure if this one would factor, but we're not even going to go there because we don't need to. They just reverse the order. So that is called the commutative property. And they've simply rearranged the terms. Number 15. Lewis multiplies b by b and then adds 10b. He then divides that expression by 2. He writes the expression b times b plus 10b divided by 2. Which three expressions are equivalent? So he has b times b plus 10b, all divided by 2. Now remember a minute ago what we did when we had a fraction like this. Remember, you can break that fraction down. But before I do that, let's focus right here just a minute. What's another way to write b times b so that we don't have to look at that big string of b's? We can call that b squared. So could I say b squared over 2 plus 10b over 2? Is that legal to do that? Sure it is. I can do that as long as I keep that denominator with both. So D is one of my choices. And how many did we need on this one? I'll have to scroll back up to see. I know that D is one of them. We need 3 of them. So let's do a little thinking here. Look at this part and see if there's anything that you could simplify. Yes, right here I can say 2 into 10 is 5 to get 5b. So then I'm left with b squared over 2 plus 5b. That is option C. So that's one of my choices. We need a third one. Right? Yes, which 3 are equal. Well, let's think. Could it be A? No, there's nowhere in there to get a 6b. A is not the one. Could it be B? The 5b is okay. This part is okay, but we've lost one of those b's and we've also lost that denominator of 2 with the b's. So the 5b is okay, but not this first part. That first term is not correct. E, 2b is not the same as b times b. 2b would be b plus b. So E is not the one either. So what about F? Could that one be? Absolutely it could, because it has the b squared and the 10b. It has the denominator of a 2. So F is your third correct choice. Very little math to be done there. I did some basic division, but that's it. This is a thinking problem, and it is not easy. Number 16. Which expression is equivalent to x divided by 10 minus 3 divided by 10 plus 10y? So we have learned, we've seen a lot of these, or not a lot, but we've seen a few of them, that when I have that denominator, a common denominator, I can write that one time and then combine the top part. So do we see this choice? We do. That one is D. You just use your denominator once and combine your top terms. Number 17. Lauren buys and sells different crafts at a craft fair. Her total balance can be represented with the expression, which other expression represents Lauren's balance. So I have 5W plus 10S minus 2W minus 4S. Now my first thought is to combine like terms. So let's see if that works. It may not. We've seen them before here that do not work. 5 minus 2, that's 3 W's. And then we have 10 minus 4, that's positive 6S. Then I could factor out a 3 because both of them have a 3 in common. So I could take the 3 out. I would still need 2 to make that 6 and then S. So then let's see if we have a common link to our answers. And I do. We have this factored expression right here. For me personally, it's easier to get these answers and try to match them than try to work through all of these. Now some people like to do it the other way. They like to take each of these and try to get those to match over here. But for me personally, I like to do it this way and then work back to my answers. But you can do it either way. And finally, number 18. A store offers a promotion of buy 2 towels and get a discount of $7. George buys 12 towels. The total cost can be represented by 12T minus 42. Which expression can also represent the amount that George paid? Now when I look at these answers, I see parentheses. So that tells me that they have factored to get their answers. They have broken down the original expression. So that's what I'm going to do. Now if it is clear to you what the factor is, you can go with that. If you don't know what your factor needs to be, we know we need to break it down, but we need to figure out how to break it down. So we have 1 times 12, 2 times 6, and 3 times 4. And then let's write our factors for 42. We're looking for the greatest one they have in common. So you have 1 times 42, 2 times 21, 3 times 14, 4 won't go, 5 won't go, but 6 will. 6 times 7. So the greatest common factor is going to be this 6. Okay. So I'm going to factor out a 6. I can tell you that it's going to be either A or B. Alright, so 6 times 2 makes 12, and there's the T. And 6 times 7 makes 42. So the answer I'm looking for is B. In my opinion, this is a very difficult lesson. I would expect you to have questions on this one. If you don't, that's wonderful. That's great. But if you do have questions, you need to talk to your instructor. Make sure that you get those questions answered before you try to go further, because this is advanced material in my opinion. So please don't hesitate to reach out if you need help. And I will see you in the next lesson where we'll be using these expressions to solve word problems. I hope you have a great day, and I'll see you soon.